In example 9, it says use a calculator to estimate the absolute maximum and minimum values of this function. And they give you an interval from 0 to 2 pi, and then it wants you to do the same thing using calculus. So what I'm going to do is use calculus and kind of minimize our work on the calculator, since in this class you won't be able to use a calculator. Although we are going to use a calculator a little bit near the end to decide on what our max and mins are. But remember, on a test, there'll be easier values, so you'll be able to do it without. So I've got a function to find absolute max and min. We want to find the derivative and set it equal to 0 so that we can find our critical numbers. We're then going to take those critical numbers and plug them into the function, and we're going to take our endpoints and plug them into the function. And whatever number is the smallest is our absolute minimum, and whatever number is the biggest will be our absolute maximum. So let's find the derivatives. The derivative of x is 1. Then I've got a coefficient of -2 that'll stay in front. And then I do derivative of sine is cosine. So there's my first derivative. Now I'm going to set this equal to 0 and find my critical numbers. So I'm going to subtract 1 to the other side, and I'm going to divide by -2, and I get cosine equals 1/2. Then I'm going to do inverse cosine to the other side. And then I want to know what x values give me 1/2. So with a calculator, you could plug that in. You also could remember your unit circle, or you could look at your triangle, your special triangle. You know, cosine is adjacent over hypotenuse, so I could label that. And this would be my 1, 2, rad 3 triangle. And we know that 60 degrees is always opposite of rad 3. So then I'm looking at a 60-degree angle here, but we're in radians. So that's going to be pi over 3 in radians. And cosine here is positive. If you think about all students take calculus, cosine is positive in quadrants 1 and 4. So quadrant 1 is your pi over 3. In quadrant 1, it'd be 5 pi over 3. So those are my two critical numbers. And then we've got our two endpoints, 0 and 2 pi. And we're going to plug all these into my original function. So notice I'm putting f, not f prime. The derivative was only used to find the critical numbers. We're now finished using the derivative. We go back to the original function and find the y values for these. So if I plug in pi over 3 for x, I get pi over 3. And then I plug in pi over 3 for x and the sine. And I do the same thing with all of these. So let's just go ahead and write it. Plug in 0 and plug in 2 pi. All right, now we evaluate. So I've got a triangle over here, which is pretty useful. Sine of pi over 3 is going to be rad 3 over 2, because you do opposite over hypotenuse. So I've got pi over 3 minus 2 rad 3 over 2. And if you want to simplify that further, your 2's cancel. So you've got pi over 3 minus rad 3. In 5 pi over 3, you're going to get the same thing. You're going to get rad 3 over 2 looking at your 60-degree angle, but 5 pi over 3 is in quadrant 4 and sine is negative there. So you're going to get 5 pi over 3, and then it'll be, well, let's write it, -2 and negative rad 3 over 2. And so your negatives cancel, and so do your 2's. Here I'm going to have 0 minus 2 times sine of 0. If you think about your unit circle, sine at 0 is, we've got the ordered pair 1, 0, cosine sine, so sine is 0 there. So I've got 0 minus 0, which is 0. And then I've got 2 pi is the same as 0, so sine at 2 pi is also 0. That'd be 2 pi minus 0. All right, so then we need to figure out which number is the biggest, which number is the smallest. If we look through here, and then this is where you probably will want a calculator to figure out what's the smallest and what's the biggest. When you do pi over 3 minus radical 3, you end up getting negative 0.68. When you type in 5 pi over 3 plus rad 3, you're going to get 6.97. And then we know pi is 3.14, so 2 times 3 is 6 something. So you can think of it that way. It's 6.28. And then we just pick out our biggest one, which is this one. The 5 pi over 3 is going to be our absolute maximum. And the smallest one is our negative, the pi over 3. So we've got an absolute max at 5 pi over 3, comma, let's write it in exact values. If the 2's cancel the negatives, it ends up being 5 pi over 3 plus rad 3. And then our absolute minimum is at pi over 3, and then that'd be pi over 3 minus rad 3.